Hello and welcome back to another session of Pistonics. It's Byron speaking and we are building Catchit. Catchit is a game that by now actually is a game. And as you can see, you have to, there we go. You have to avoid these obstacles here that fly around at various speeds and angles and they bounce off. And then there are these nearly hidden white ones, which in fact don't kill, but they do something. They have an effect. And the white ones have the effect of fading out the other ones so that they're invisible for a moment, which is super evil if you think about it. So this is something we have to implement now, and it's going to be fun because it's kind of the first animation that happens. We have a state and we want to transition from one state to another without fucking up and things like that. So let's see how that works. It's more like, it's more of a management task than of a gameplay task, that is. So, yeah. So first of all, at some point we create these, during update, I might actually want to, let's factor this out. And also, speaking about factoring here, let's have a public API and a private one. We already have that, but let's separate it because what I didn't know, you can have multiple impl statements here for the same type. You can just go ahead and keep implementing stuff and it will be fine. So I know this happens if you have generics in here, because then you can have different implementations for different types in there, but this also works for the plain simple ones. So here are the pubs, and that's all pub. Cool. So then I would say, well, I would like the update to look as simple as possible, and the private stuff should be private and put elsewhere. So what about putting this here, and then putting the public API into its own impl. So that should be that. And then the next thing is something like create ball, create obstacle, right? And we just put this code elsewhere so that this will not be a problem. This will not be visible anymore. And we kind of see what we do. We want to set the score, and then we create a new obstacle. And this is what all this code does. But it looks like a lot more. And I think we do ourselves a favor by doing this correctly. We have to watch it. So here, so here we create an obstacle, right? So this is the obstacle creation code. This is where we would like to do something else. So self new obstacle, and that should be all we need, right? So fn new obstacle mod self. We will change our state, and I think we should take this state because we happen to have it here and it's otherwise an optional. So let's have a state which is mutable like this, and it's called s just because it's our internal function and we want to keep things short and spicy. Yeah, that could be it. So new obstacle gets a mud s, which I think can be passed like that because it's already a mud state. So let's see if that works. And here the collision. Yeah, we also, let's refactor this a bit just for the fun of it, because this will only get more complex the more we add. More than once at a time. Guess what? Yeah, there we go again, because we borrow ourselves here mutably, right? This is why this happens. So the question is, no wait, where do we borrow? Where do I get the mutable borrow? There it happens. So it's kind of this thing. And I wonder, if I do not mention self here, is it then not in there? It's more like a closure thing, that the self is caught there, even though technically it just stayed. Yeah, but no, on the other hand, if I wanted to make a call here, then technically this function has full access to self, and no, I can't work around that. Maybe I can work around it by setting... What if I put a lifetime in here and say, well, listen, the lifetime is the same. Maybe it doesn't know that. Here you go with your lifetime. Here you go with your lifetime. And maybe that works. Probably not, but it would be cool. And I don't know what I was thinking. I totally don't know what I was thinking. So here we go. Ugh, it looked odd when I was writing it. Cool, cannot borrow self, previous borrow is there, and it's the same thing. So actually not cool. Totally not cool. Yeah, so what could be done obviously is, I mean, wait. We can think about that. Do we use self here? Yes, we get a borrow. Actually, what if we took... Oh yeah, but we have a mutable self. I was thinking if you have an immutable self, also doesn't work. We only change the state and we use our type. So this could very well... there's a min distance. That's a cache. Damn it. Yeah, so in these situations, the borrow checker happens to be a bit nasty. And I wonder if it really has to be like that. So in theory, we could do with an immutable self actually, but I don't think this will help. But let's see. I will try anyway, you know? So as immutable, because it is also, so part of its state is also borrowed as mutable. Sure, it kind of makes no sense, huh? Yeah, how do I get this code elsewhere? I must be able to make the borrow checker happy and myself, because I would rather do this instead of anything else. Yeah, so again, this doesn't need to be mutable, so that's a good thing, but we just cannot call it here. We could copy the entire state, of course, but hey, come on. That would be very annoying. And there doesn't seem to be, I don't know, does it make a difference if I do an asref as mut here? Then I get also a borrow on the state, which I can then pass on. I mean, he is right. No, wait. Yeah, I mean, whatever I do, it will remain a mutable borrow there, so I can't change that. Yeah, so of course what I can do is have a separate function that takes a mutable self as first argument. No, wait, takes what it needs as first argument, or as arguments in general, so that self is not included here anymore. So we would factor that out and say, well, it's a type method. Let's do it. It's a type method, so that way we can do it like this. And probably it's a good thing. So here we have the RNG that we need. So let's have it. Mut XOR shift RNG. That's the first thing, so we don't need that here anymore. Like this. And then it's actually like this. So we basically have to take out everything you want to use here. And yeah, then it's min distance. And that's it. I don't know if that makes better code. I mean, for us, it's still better. But I'm not sure if that is generally a great thing to do. Well, anyway. There's no... It is like that, but I have to refactor this. So let's do it like this. Then we go with self min distance. I can have read-only access to this, right? Or will it... I think it should hate me here. Probably hates me here as well, huh? No, actually, if it would hate me here as well. It's interesting that I cannot make a function call, but I can use self here because it does know. Yeah, well, sure. Here it knows what I use and what not. In the function, it doesn't know. It's just concerned about the signature and what could be done. I think this is how you have to see it. Okay. See, I'm still kind of trying to improve my understanding. Of how this works. But I think I'm fine. I'm good with that. X or Shift RNG. Excuse me. Oh, it's rand X or Shift RND. Yeah. Maybe I want to import this at some point, but RNG. Can I borrow immutable local variable RNG as immutable 179? 179. Yeah, I think that shall be fine now. And that as well, and now this is that, and now that is that. So the code looks a bit better, that's for sure. So that was the refactoring, and then the cool thing is we have a better overview of what's happening here and what we are doing, I think. Even though I would now actually not want to... Yeah, do I want to factor this one out as well? I could. It's really just, yeah, I could call it advect obstacles, right? And I would have to make it, yeah, I don't need a mutable self here, but I also cannot use self at all. Let's not forget that, not within this branch here. So it would need to be a class method again. But I think it's okay because, yeah, let's do it now that we are in the business and know how this works. So it's self advect obstacles, and it gets our state here. So fn advect obstacles, and s shall be a mut state, and that's all, right? Totally. Cool. So that should possibly work right away. And now we kind of clean it up a bit. No. Unresolved. Oh, DT. Yeah, sure. So delta time we should probably provide. It's an F64. DT F64. And there we go. So now it should work. It works as before, and we can think about how to implement the special handling. So first of all, when we create a new obstacle and we determine the kind, where do we determine the kind? Here we do. So we have this one. Let's do it like that. Yes, nice. We have deadly ones and the invisibility switches. Let's make it a bit less likely though. And if that's the case, I think I would also like to increase their size. So that's currently based on hunter size, but we could also set this up here as a first thing. And we call it a mut. And then we say, well, these things are twice as large, something like that. So these guys are now a bit more special, because I will always also set the half size times 2. Like this. So now they're bigger, thus easier to hit. Yeah, like that. So that's the only thing we can do right now. And the thing is, in the moment we do the collision detection, we want to say, well, what kind of type is that? Let's match on the obstacle kind. And if it's an obstacle kind deadly, then we do what we do. Then this makes total sense. Then we intersect. Oh wait, we always intersect with it. No matter what. Something happens if we intersect anything. That's for sure. But then we determine what exactly happens in here. So the game over code should move right here. Ugh. And there's a fat reflection right where I'm typing. Maybe I moved this up a bit. Yes, better. Now I see now I see more. So we intersect with it, and then this is what we actually want. So we set it to game over and break out of there. Yeah, that makes sense. So now obstacle kind, invisibility switch. And now we get to the interesting part. Now we have to set up some kind of transition that must be part of the state that is also, that can be interpreted by, that we control, but that is interpreted by the drawing mechanism. So what I would like to set up is a decay transition, which might just be it's really about the variable name here. So we have transitions that might just be first value, last value, and then a mix between, right? And we animate that basically based on the time delta or what. And then we can remain in that state for a while. And if we remain for a while, we will basically invert that transition and and kind of animate that stuff back. So what am I talking about? Let's actually show it. Chrome experiment. So let's see if we can actually manage to play to the point where we see it. Give me one. Spawn chance is quite low. So there's no white one yet. No white one. There it is. Okay, I messed up. Another time. Come on, give me a white one. Just a matter of time. But anyway, come on. Here we go. That's easy. So transition, and then, they hide for a moment. And as you can see here, this transition handling is not correct. So the more you hit it, the more it starts hiding again. But they're still there. So that's kind of the evil thing. And based on this idea of having special obstacles, you can basically implement a few more things. And I have one idea of two. And if you press left, by the way, you kind of repel these things. I didn't know that until I checked the code. And there was some handler implemented that I never used. And I would also kind of like to have that, to be honest. So that's pretty cool. No. Yeah, anyway, so these get faster and more angry the more you repel them, and I think this is also part of the game mechanic. You can use it as a last resort, but it doesn't necessarily make it better. Good. So that's what we want to implement now. I would like to have a transition somehow, and it must be based on whether or not we already have a transition, and yeah. So the thing is, invisibility. Yeah, let's have a structure that does that. Let's try to develop that somehow. So that's opacity actually. Or let's call it invisibility. So if it starts, it's opaque and then it translates to invisible. Or let's say opacity, because that kind of affects the opacity. I would prefer to do it that way around. So it's pub struct transition, but what happens there is something we don't really care about. The interpretation of this transition is something we want to leave to basically the user of these values. So that's kind of a general one, but we just use scalars as usual. So from to, and then we might have a current value. So we work in absolute values here, and then you can basically compute all the rest as you go. Yeah, I think that's something you could do. Current, let's not do the abbreviation stuff again. And it's a pub. So do what you want. And now we implement we implement something here. So how would that work? Yeah. So from to, I think the transition can be there all the time. That's the first thing. And yeah, let's have a simple implementation of stuff that I probably want to use any moment now. So fn new is basically from scalar to scalar, and then we just return a transition, which has from to, and current is from. So that's where they all start. This is what this constructor is there for, and nothing more, nothing less. Good. So let's keep a transition in our state opacity. Transition between opaque and invisible ones. Invisible obstacles. Obstacle, opacity, transition. Like this. So let's set ourselves up. Obstacle opacity is transition new, and we always start at full opacity, so it's 1.0, and we leave at invisibility, which is this one. That is that. And the cool thing is that we can, yeah, so now we need a few functions. This guy would need to see, okay, if there is a transition in progress already, then yeah, I probably can get away with just comparing values here. Let's see. So, or what's the state? It should have a state, huh? I could work with an enum, so it could be start, finished, or in progress or something. That's the states it has. And yeah, let's do that. Sounds good. This makes sure we have just one method and not three of them. So there we go. Pub enum transition state start. Transition is at start, which is the case right after calling new. Okay, there we go. Then we are neither finished nor at the start. That's in progress. We are finished. Something. Finished. Good. And now we can ask for a state. Fn. Give me the state. Read only, of course. Returns a transition state. And let's see how that goes. Yeah, maybe I just go with an if-else instead of a match here. I think that would be easier. If self from is self. You know what? Maybe match on self current, because it's all based on self current, right? So if v is self from. Then you return transition state start and a v of self 2, then it's finished. Or let's make it smaller, equal, greater than, just be a bit more flexible here. So we clamp the value basically. And the last thing, basically the default is, okay, then it must be in progress or something. In progress. Cool. So that should work. Should it? Probably. Nah. Mismatch types. It expected nothing, found a transition. Transition new probably has an incorrect signature because we want to return a transition, right? So maybe now, probably not. Oh, something happened. Method is never used. State. True, but we shall do that any moment now. Because you don't want to restart the transition, right? So if it's... So how do we do it? We could be either finished or basically... If it's not at start, then we don't do stuff. Yeah, maybe a few unit tests would be nice now, just to verify a few things about the transition test here and about the transition itself. So yeah, let's do that. Why not? CFG test. Like this. CFG test, then we have mod tests and say transition. And let's test the transition a bit. Come on. Help me. Transition. Because I say that let mod t be a transition new and starts at 0, goes to 1. Then I assert that the transition state shall be transition state start. Right, this is really what I need here, otherwise our notice will fail. And in the moment you don't even need to be mod. Like that. And something I obviously missed, which is use super. And here we just go for it and say, well, give me everything. Cool. So now we can cargo test that stuff. And we have 1 passing test. Awesome. So basically, if that is start, I want to set it in, how do I, yeah, so if this is in motion, I don't do anything. If this is at start, I set it in motion. And then we have to kind of keep animating this if it is in motion already. And something. And we might also keep track of a time, you know, we could attach a time to it so we know how fast things are proceeding or how long it is in a particular state. I kind of hacked this to work for me, even though, you know, it's not general, it's just working for me. So I really want to have a delta time or a time here, delta time that says how long we are in a particular state already, or something. Something should be fine, right? So that starts at 0, obviously, and then we go ahead. So the animation speed, you know, the drawer doesn't care at all. That's the cool thing. Just us who cares and who has to have to keep the time right. So yeah, and we have to keep the direction right. So we might be on our way back, and we have to keep track of that somehow. And we can't just invert this because the drawer will be depending on us doing this right, even though it's technically 2 transitions, right? One from opaque to invisible, and the other one the other way around. And maybe there should be some sort of direction from 2. Yeah, maybe there should be a direction, right? Because I need to keep track of that. Which value are we moving this? And maybe we also wanna keep track of the time and say, well, how much time do you need to do the transition? Maybe all we have to do is kind of keep dumping delta times. Yeah, maybe this is what we want, right? Okay, first direction, from to or to from. And everything starts at from to. Pub enum transition direction, which is from to or to from. So we have a pub direction transition direction. So, and the direction is always transition direction from to, at the start at least. So, and now this actually matters, right? This totally matters, because this would basically allow us, this is kind of first last, or 1, 2. These really have, it's really just 2 values now, value 1, value 2. V1, V2. Yeah, I think that is better done like that. From 2, that can remain like that, so that is V1, that is V2. And when we check it, we will self V1 yeah, so let's set a few values. Set start, finished, and in progress remains in progress is match on self direction, which can be transition direction from to, and then we shall return what we have here, right? Then it really is start and finished, like that. And if it's transition direction, to from, it's really just the other way around. Finished, start, like that. Start, finished, finish, start. And then we just return the values as we get them, whatever that is. So here we do V2 and V1. And see, now the test will come in handy because that thing grows more complex in terms of logic, and probably you want to test this out before you go into the game and ask yourself why the heck this is so not working at all. So that is that. It should still work. And what about the logic? So if we hit the thing, we actually don't want to do anything if we are not at start, right? So this is something we can now say. This will, if we invert this, then this will be at the finished state. And yeah, this is something we have to keep track of anyway when we update this thing. But for now, let's see how this goes. For now, all we need to know is, actually, I don't know. So if it's an invisibility switch, and if self opacity, obstacle opacity, state, maybe I just put it here, huh? If this is transition, state, start, then we actually kick it off, right? We just do the first we just give it a first nudge into the direction of where we wanna go. And there is the question: how do we do that? Maybe there's just an advance, so maybe we can set it explicitly. But we should make the computation as easy as possible. The time should be a factor here. So we really just advance it by a delta time. This is kind of the interface I would prefer here. And let's do it then, huh? So we can advance the transition so it gets towards the finish state. Move transition towards the finish state, and we shall return a mutable so that we can chain this just for the fun of it. Mat self, and dt delta time is an f64, and we shall return a mat self. Right. So that should already satisfy the advanced signature. Pop direction 135. Probably there's some syntactic issue there. That's the one. 153, comma missing. Jesus. And now 155, semicolon missing. Awesome. Every possible bug, syntax error I put in there. Attempted XOR field obstacle opacity, but no field with that name was found. Really? But I put it here, right? I put it into the state. Yes, I probably tried to access it on self. So it's on S, obviously. So that's more like it. Yeah. Never used. Okay, so now we need to have an idea about the duration of that thing. And can we use duration already? I think the duration type was unstable here, or you have to get it from a different crate. Duration, maybe we get it from Piston somehow. Let's see. Duration, equation, no duration. STD time duration, are you stable, please? Oh no. That's so sad. I love duration. Duration types are great. So now, because that way you kind of can't get the unit wrong anymore in these times, and that's so much better. So now you have to document what kind of time unit you wish. Yeah, anyway, we are a little engine and we just work in seconds here and provide fractionals of these seconds. dt is in seconds. So, and signals the past time since the last advance call. So in theory, we could say, well, so the thing is, the way I implement it now, it's kind of, you can't do fanciness. It's just a linear advancement here. But it's something we compute, and possibly we can have transitions that are nonlinear, but then we would have to set it up. So right now it's just linear and we only know this one. It's a linear transition. I think that's decent enough. That way we can keep the computation kind of in-house. And we just need to know, how long a transition takes. Transition time, right? Pub transition time is an F64. Transition time in seconds, yeah, why not? Time it takes to make one transition. And that allows us to compute the value accordingly and do stuff. For the drawing, it will be super simple to implement that way. And for us, it will be super simple to use. I think it's a win-win if we implement it like that. So there is a transition time that we want to set, and that's something we definitely need. Transition time S shall be an F64. Transition time. S is transition time S. Thank you. Good, and now we can compute stuff. And yeah, I would like to keep the current value always in a valid state so we don't overshoot. So I guess if we are not finished, we do something, right? So if self state is not finished, and that's kind of an expensive call because we do all this, right? But we have to do all this because of the advancement, and we have to get the direction right. Yeah, so yes, we have to do it. Who cares about performance? This will still be super fast. I mean, for what we do, no problem. No problem at all. So if the state is not finished, then we can advance this. Transition state finished. Then now we have to compute the advanced direction. And I think the advanced value or the advanced amount, like this is what we want to do. And we will multiply this by a direction depending on where we are going, basically. So if we go from end to start, then we have to subtract this. Where if you go from start to end, we have to add it. That's how we do it right now. Yeah, so this means negative values or something is something we can't do, really. Oh, wait, maybe we can do it. We just have to... Yeah, so we basically just compute. Let's have functions that are from and to. Yeah. Fn from. That returns a scalar, right? So that matches on the direction here. And just returns v1 or v2 respectively. So if it's from 2, then it's self v1. And if it's to from, it's self v2. All right. And like this. So does it work? And maybe I remove this for now. 180. Yeah, probably this will not work anyway. Yeah, I hate it. Why did that happen? So is it here? No, that looks fine. 236, what did I even do there? Well, we definitely need a transition time. I think 0.5. Let's have a pub const transition duration, which is a scalar, and it's 0.5. Like that. So what's this problem again? Okay, there was no problem. He was just telling me that it was missing an argument. I should read more. All right, so from Fn to, it's kind of the same thing, but inverted. V2, V1, funny. There we go, that's implemented. I could test for that, but right now I don't feel like it. On the other hand, maybe I should. So assert equal from, that's 0.0, and 2 is 1.0, then we could invert direction. But I think I would do this after we have advanced a few times. Oh, and here we obviously need to put a transition duration. Why not? Duplicate method. Ah. See, copy paste. Forgot something. I thought I did it actually. Maybe I've undone it accidentally. All right, testing. Also works, fine. Good. So now the advance. So basically we scale how do we do it? First we get the entire domain here from 2. And then we don't have to invert signs or something. Then we can also deal with all the values that are there. So it can be in the negatives and the positives, whatever. We will always advance towards that thing. So end 2 minus from. Oh wait. And the state we wouldn't have to check, right? This kind of happens automatically then. Because if we are there already, then our algorithm should basically add 0 or something and thus do nothing. So we can be stupid here and don't have to use conditions. That's something I would prefer. I mean, there are conditions in there and from and to, but yeah. So let delta be self to minus self from. And now we have to scale this delta and add it to current. So at the end we have self current plus delta, which needs to be scaled in some way. And that should always work. So scaled in some way, obviously we have to put dt in relation to dt in relation to the transition time, I think. Plus equals delta times so 0.5, 0.1 would be 5, or 0.1 1/5. Yeah, so maybe this by self time, transition time. So if this is, for instance, let's say at 5 and this is 1, then it's 1/5, and then we add 1/5 each time to the delta. So I think that's kind of what we want, so that we need 5 steps in that transition or with that delta to get to the right value here. And we add it, and we might, this is all floating point stuff, we might overshoot, so I might want to clamp that. So if self current greater, because we don't want this to overshoot ever. So let's be sure we don't. Let's just be safe here. Self current greater than self 2, and then a way we could save that, let 2 be self 2, and then we save this call greater 2, then self current is 2, and that is the implementation, I guess, and return self. I think that's it, and that way we wouldn't have to check for anything really. So that should make it really, really easy to do it. So let's advance this for a moment. So assert equal. So transition time, let's make it just 1 here. And if we advance this, by 0.5, then current should be 0.5. Right? It works. And the state is in progress. Yeah, so now if you do that again, then the state should be finished. And we are done. And current is 1.0. So that's the whole idea, right? Boom. That actually works. And now we invert it. Let's reverse it. Let's have a function that is called reverse. And this is stuff we could actually put into submodules here, right? This is a perfect candidate. It gets larger, and then we can split it up a bit, be better. But we will do this in a separate session, I think. 51 minutes in, and we just have the basic transition there. Maybe it's very fast now, so let's hurry up. I actually would want to continue this until I see some animation going, which should now be relatively simple with that stuff. So yeah, reverse. Fn reverse is mod self. And it returns itself like this. And well, this is we can clone this. So match self direction, so that we can change it here. Maybe we can even change it anyway. Let's see. Transition direction from 2. Now we change it to self direction is this. We just invert it to from. And if it's to from, change it to from to, like this. Does that work? Let's see. So we let's just do it. Let's just do it here. Let's reverse this, and then we can say, well, now this inverted. So this is now 1 and it goes to 0. And the state is start again, right? 198 could be right if we would do that correctly. Always forget this. And sometimes I have the feeling it doesn't run the test, but it does. So yes, that's correct. That works as we think it should. Which now means that we can do the same, play the same game again. We advance, it's in progress, but the values change, obviously. We advance and it's 0.5, state is in progress. We advance again, it's 0 and state is finished. So that is what I would expect, and that's not the case. Oh, look at that. Something is wrong. Maybe my test is wrong. 416. So current ends being 1. And this is a precondition here. And that's still supposed to be the case. So here the advance doesn't work. The state, though, does work. So left is 0, right is 1, 416. Oh, actually, that's the precondition. Right now it's 1, right? Yes. And then left is 0, 0.5 is on the right side. So if we advance this 1, then it all of a sudden gets to 0, which is something I actually do not expect. So this reverses, and current is still 1. And what the heck? So what happens? And why does this not work? I thought the math behind it was bulletproof. Maybe it wasn't. Probably it wasn't. So also signedness and stuff should just handle itself. Yeah, so it should definitely go. So what happens? So it's -1. And then we get minus 0.5. Minus is plus. So 1, yeah, I don't know. What does it try to do? Why the heck does it not work? I use to and from. So from that point, I should be fine. Delta time, transition time. Probably it's this thing here, the clamping. Because it could also be, you can't say it's greater or smaller. This doesn't work. It's really about what 2 is in relation to from. So if 2 is greater than from, then you can do it that way. Let from be this. So let's do it. Yeah, so if 2 is greater than from, then this is what can happen. Oops. Otherwise, if current is smaller than 2, then set it to 2. I think that's the way this goes. Mm-hmm. One, 4, 3. Botch the syntax again, but here, really? That's weird. How did that happen? Did you mean to close this delimiter? This file contains an unclosed delimiter, 431. So probably here, huh? Oh yeah, here. Yikes. This is why it looks so weird. Yeah, so that one. Yeah. Cool, so now it works. Nice. We found a bug thanks to unit testing. You should never be too lazy to do that. Good. And now, again, now the transition stuff should be super easy. 58 minutes in. If it's so easy, it will work right away. So if it's finished, do we have to do anything? If we hit it, yeah, if it's in progress, we don't do anything. Otherwise, we set it into motion. So it's this. Advance by the delta time. Thank you very much. And this basically sets it into motion. Then, if we are in progress on this one, handle advance transition. So this is for all the transitions that they are. If the state is not start, then we advance it, right? Is not transition state start, then advance it. As obstacle opacity And we could even imagine having multiple transitions or putting that into an array. You know, once we have multiple of these, we just iterate over this. That should be easy enough. It is easy enough. There's no should there. It is just like that. So we advance it by the delta time and we are good. So that is easy. Deals with the directions so far. So if it's not start, we just advance it. If it's finished, so yeah, we still have to figure out a time. We have to realize how long we are in a certain transition, so that we can say, well, when it is a time to reverse that. And right now we don't have that information. We just advance it, but when do we reverse it, huh? And I would like to be stupid here and say, well, maybe just count the advancements. So if it's not start, then it could also be finished. Does it matter to us, really? Yeah, it does. So if it's not start, we do something with it. Well. Actually, the direction for us matters as well. We have to keep track of whether it's to from already, and let's just say, okay, this means it's in progress, but it might be finished. So let's keep the state, I guess, huh? Maybe we should match on the state. So that we get, for now I would even not mind to just reverse on the moment we are finished without keeping track of the time. So it kind of fades in and out real quick. Let's do it. Let's start easy. So transition start is nothing for us. We don't, oh wait, actually we do if it's from 2. So no wait, yeah, if we've just reversed it. So if it's a to from direction, then we want to advance it. So if the direction, yeah, that's, you know what? For t in, let's just do it right away, shall we? Yep. For t in these guys, and now it's much easier. T state, t, we are going to change it. Mutable once. Like that. Good. And in progress, then we advance. This is this one. And we say t advance delta time. Okay, and we can kick this out, put it into the loop. As you can see, I see multiple transitions coming up, but even if not, I really want this in a small variable here and maybe in its own scope. And the optimizer can just put this away as he likes. You know, if you end up having just one opacity, fine, but I like to have multiple states that we can kind of count here. And yeah, it's always an intermediate thing, right? So we go in and we go out, and that's how that goes. Yeah. If it's in progress, if it's at the end, if it's finished, then we see if we have to reverse it. So if t direction is transition direction from 2, then we say t reverse. And yeah, I think we advance it in the next tick. It's just like, okay, we stand there for a moment and then next tick we just go ahead. Otherwise, I think we would travel too fast there. And the advancement, yes. And if we are at the start, we have to check if we are at to from, because then we want to reverse it again, and we are good. And we have to check the direction here as well. So we don't want to kick this in again. Or we don't want to... Oh, actually, yes, we could do that. This would still work for us. If this is in the opposite direction, then we would basically say, well, if you hit it with your mouse, then we advance it one extra step, which is 1/60th of the full transition, after all. So this is real fast now as well. Both of these are just taking half a second. So yeah, anyway. So to from, so basically reverse it back to the original, and that is that. And maybe, you know, we can put this like that, even fits. Then we reverse it. Same here. And reverse it. So now we are actually non-exhaustive anymore. And even though we saved a little bit of space here, maybe it looks better, I would not want, yeah, this is not. Do I want that? No. Okay. So now the state should maintain itself properly. Should. And I kind of have the tendency to say, and as obstacle opacity, direction is transition direction from 2. Let's not advance it an extra step. Then we advance it. So that basically kicks it in. Otherwise we don't do anything, right? Good. Cannot borrow data immutably in a reference. Sure. Can we do an itamat here? Probably we can. Yes, we can. Cool. That totally works. So now the last thing is to change the way we define color for these black ones. So where is the color here? So this one is now actually a new color that we will mix. So we use S obstacle opacity current, and that's a vec4 color. Yeah, shit. Yeah, do we have some color mixing functions that deal with alpha correctly? That would be cool. What color stuff do you have for me? Graphics color. Alpha, gray, semi-transparent. Come on, there must be some mixer stuff, man. Don't be like that to me. Types color. Maybe color can do stuff. Nope. Oh, come on. Some mixing. Nah. No, nothing. Oh, blend color. I've seen it. Draw state blend color. Blend channel. Is there some trait or something that I'm missing? No, not really. But there is something with blending. Can I blend stuff? Or one of two. Okay, so probably I can draw and then have a blend mode, like a compositing state thingy. Blend value. Source alpha, destination. And then what? Blend preset. Image pixel blend. Yeah. I think it would be easiest to just do it myself. So, yeah, I think for the alpha, yeah, I think for I in, let's just do it like that. For I in 0 to 3. And then we just compute the new color. I would like to initialize this with 0 or something, but maybe I don't have to. Maybe it realizes that I initialize it later. Let's see. So color shall be color component actually times 3 times 4. And then we say, well, C3. Let's see if it can figure that out. Probably not. CI. Let's set this to 0 here, just for the fun of it. And I think we need the color component type from somewhere. Graphics. Where do we have some color stuff? Nope. Color component. Is this? No. So I think we can get this from here. Use graphics types color component. Like that. Cool. So here we have that, and in theory, let's return the color for a moment. Oh, it's a matte as well. Let's see if that even works. If it can determine that I don't want to set this possibly uninitialized value. That is not true. It is not possibly uninitialized. Yeah, so that's sad. Now you basically write that value, even though you will overwrite these values later. Yeah. Well. Color component is, let me set it, 0.0, 0.0, 0.0, 1.0. There we start at a beautiful black. We even have standard ones, huh? It actually is possible. Helper method for colors. To say, well, give me, here, black. Graphics color. Oh. I even defined the black myself here, huh? But my one is not really black. Yeah. Actually, I can start at black and not care. What do I care? Because it's copy anyway. Good, like this. So now we are done. And say, well, obstacle, opacity, current from 2. So that could be 1, right? So we want to start at 1 here. That's the point. Yeah. Let's try that. Let's just try it, even though I didn't test it, but it should work both directions. Just have to be sure I initialize it correctly, because I'm not sure about that. Where do I initialize that? Transition new. Ah, good. It starts at 1, goes to 0. Times black eye plus 1.0 minus this. So that's kind of alpha blending that we are doing here. Or I think overlay blending. Minus, oh no, it's here, plus 1 minus that times, and then we blend with the background color, BGI. So that should be the nice blend value, and we return C, right? And the thing is, we kind of compute this for every... Do we compute this once? Yeah, for each obstacle. So let's compute this color just once, please. Let deadly cull be this. And that will look much better. Deadly cull color. Let's take this to the maximum and give us these extra characters. So like that, thank you very much. Computed once per tick, that's what we want. Then we drop it in, and that should now build and work and be nice. Nearly. Obstacle opacity. Because it's an S, of course. There we go. No! It is not implemented for type F64. Oh, yeah, true. That's an F64, and these color components are F32. Well, I will just convert it then as F32, and that should work better. Color component is not required anymore. And now we can run that thing, and it should actually work. It should then animate our stuff from one to the other, provided that we survive long enough to get a white one. Give me a white one. Ugh. Every 10th kind of, or even more rare. Oh, damn it. Very fun. Oh. I might actually want to increase the chance for a white one. Oh. There's no reason not to focus here. This is quite mean, especially with these fast ones. Huh? Maybe I want to slow them down. There's a white one. There's a white one, and it's even bigger. All right, I hit it. But not. Oh, there we go. But it didn't come back. They didn't come back, but it happened. Yeah, and this will only scale them. That's okay. I'm fine with that. So let's make the chance 50-50, and we will test that a bit more, because that definitely doesn't work here. But it's cool. I think we will leave this to the next session. Like, excuse me, chance is now much higher. Why do I not see like 10 white ones? Okay. I think this weak RNG is just shitty. Okay, they're gone. But they don't come back. Okay, but we have to test it in the next session. Some debugging might be required. Thanks for watching, and have a great day.